Hi everybody. This can be fun, but hopefully it'll only be a couple of days. So we're on section 1.4, which is about functions, and it should be familiar because we've done some function stuff before, but don't tune me out completely because the domain stuff is a little bit new. So I've made up 3 functions here, each written in function notation. So remember that function notation gives the name of the function. So this one is called f, and then it tells me which variable is used in that function. So this is function f, and it has the variable x, which is obvious. But later we might use 2, so it's important to know which is the variable. And then this function's name is g. It has the variable x in it, and this function's name is h, and it has the variable x in it. So what we're going to do is operations with functions. So I'm going to go through each of these, and then we'll talk about the domain of each one, and then I'll be finished talking, so you can count it down as we go. So we'll start with f plus g. It's just as obvious as it seems. You literally do 3x plus 5, that's f, and then x squared plus 1, minus 1, that's g, and then I combine as much as I can, simplify this little expression. So I don't have anything to combine the 3x with, but I can do the 5 and the minus 1, so that's 4, and then plus x squared, and ta-da, this is f plus g. So that part is pretty simple most of the time. We just simplify as much as we can. But then we're asked to find the domain of each of these. And for this whole first section of normal operations, so this whole bit and above, here's how you find the domain. You find the domain of f, and then you find the domain of g, and then you tell what they have in common. So what's in both of them. So the domain of f is all real numbers. I can plug in anything I want. The domain of g is all real numbers. So the domain of this function is all real numbers. We can do that little symbol. We can physically write out all real numbers. We're going to abbreviate because I'm running out of space on a little paper here. Or we can use interval notation, negative infinity to infinity, whichever way makes you the happiest. So then I have f minus h. Again, it's going to be just as simple as it seems. So I write f minus, and I do have to be careful when we do the minus that I put this whole function in parentheses to make sure the minus goes all the way through. In this case, there's only one little thing in the h, but if we did f minus g, it'd be 3x plus 5 minus parentheses. We'd have to subtract that whole thing. So I simplify as much as I can. In this case, there's really not much that could be done. But we don't look at the function as a whole for the domain. We look at the pieces. So the domain of f is, again, all real numbers, just anything you want. The domain of g, which isn't in this problem, but again, you can plug anything you want in. It's all real numbers. But the domain of h is a little more specific because we can't plug in a negative number. We're talking about real numbers here. So here, all of this has to be just positives, or the x is greater than or equal to 0. So the domain of f, I got off the paper there. The domain of f is all real numbers, and the domain of h is anything above 0. So what they have in common, the numbers that are in both are the numbers greater than 0. So if one of them had a domain of only positive numbers and another one had a domain of everything from -5 to +5, well, then the overlap, if we kind of picture a number line, if one of them has only positive numbers, okay, so that's from 0 to infinity, and the other one only has from -5 to 5, then it would go here. The overlap is the domain of the resulting function. So the domain of one, the domain of the other, and where do they overlap is the domain of the combined functions. This part doesn't get any harder. Fg is just f, 3x plus 5. Note that I put that in parentheses. And then g, x squared, minus, why do I want that to be a plus? X squared minus 1. And then I'm going to FOIL those two out so that I can see if there's anything to simplify. I'll get 3x to the third. That's first, outer, inner, last. Okay, so this is FG. What is its domain? Well, the overlap between F and G, which we already set up here, was all real numbers, because all real numbers is the domain for F, all real numbers is the domain for G, so the overlap is all real numbers. All right, now this one gets a teeny bit trickier, but still not bad. We write F, 3x plus 5. We write H, square root of x. There's not even really anything to simplify here. We could rationalize, and it's not a bad time to remember what that looks like. So square root of x times 3x plus 5 over x. We could rationalize, that isn't mandatory, but we technically could get that square root out as part of our simplifying process. But either form of this, whether it be this one or this one, is going to have the same domain. And if we look at those two functions, f is all real numbers, and this h, its domain is x is greater than 0. So the overlap is the x is greater than 0, except we have to check one more thing when we do division. Our denominator still can't be 0. So now we have to eliminate the 0. So it has to be x is greater than 0. That's our domain for this combined function, because x can't be 0. So this one is a little different from the other three operations, because we also have to make sure that we don't make our denominator 0. So any number in our domain has to work in this one by itself and in this one by itself, and not make the denominator 0. So it has to meet all three of those qualifications. So there is how to do those 4 basic operations. All of these are just kind of different ways of writing exactly the same thing, which is called a composition of functions. That's when we put one inside the other, which is something we have done before. So this one, which looks like fog, this is actually a tiny little circle. That's easier to see when this sort of thing is typed out. But it means f of g, and that means we take g and put it inside f. What does that look like? Well, g is x squared minus 1. So we go to f, and everywhere there's an x, we replace that x, so it's 3x plus 5. I replace that x with the entire function of g, x squared minus 1. And then again, we simplify as much as possible. 3x squared minus 3 plus 5, so I distributed through, put those like terms together, 3x squared plus 2. And now, this time we don't go back and look at the individual ones. We look at the new thing that we've made. What is the domain of this thing? And the domain of this thing is we could plug in anything we want. We don't have any square roots to consider. We don't have any denominators to consider. So this domain is all real numbers. This means the same thing at first, but it means we're going to put f inside of g, but it means that first we're going to put 2 inside of f, then we're going to put f inside of g. So we put a 2 into our f function. So everywhere there was an x, I replace it with a 2. So f of 2 is 3 times 2 is 6, plus 5 makes 11. We've found what we get when we put 2 inside of f. Now we take that answer and put it inside of g. So we're kind of working our way backwards there. So that answer, 11, goes inside of g. So I replace all the x's here. 11 squared minus 1. That's 121 minus 1, which is 120. This one isn't going to have a domain. This is a different situation where we're literally plugging something in. We're now evaluating. We gave it a value. We don't have to worry about the domain of this one. Now here I left the x in, so we are going to talk about the domain again. This is another way of writing exactly the same thing. So this means, I think a little more clearly, that we're going to put f inside of g. And we're not going to plug a number in, we're going to leave that x in there. So we're going to put f inside of g. G is x squared minus 1. So we're going to replace this whole thing with the function f, 3x plus 5. Okay, this one's going to be a little longer. So I FOIL that thing out. That gives me, sorry that it's crooked, 9x squared plus 15x plus 15x is plus 30x plus 25 minus 1 simplifies to 9x squared plus 30x plus 24. And we're finished doing g of f of x, which is how we read this. This one we read f of g, g of f of 2. So I finished plugging it in. If I want to know the domain, I don't have to go back to the original f and g like I did up here. I just look at this. And because it has no square roots or denominators, again, that one's all real numbers, so I did not choose possibly the very best examples that I could have. All right, let's try, we kind of already did this one. F of g of x is the same as f of g written this way. Okay, so let's do it with an h, just so we can have one more example. I won't mess up your countdown too much. Okay, so now I'm going to put h inside of f. So f is 3x plus 5. I'm going to replace the x with this whole function. So it's going to be 3 square root of x plus 5. Why? Because I replaced the x with that whole function. Did it? Not much simplification right here, except that we look at this function and we ask ourselves, what am I not allowed to plug in here? And again, we can't plug any negative numbers in there. So my domain is x is greater than or equal to 0. We can plug a 0 in there. That's allowed because the square root of 0 is 0. We can't plug a negative because that would give us imaginary numbers, which we're not really messing with right now. Your assignment is on page 124, which for some reason is not written here, but it should be on the assignment board. There's your assignment, not too very many. So there you go. And I am going to do my best on Monday to be live for at least part of class so that I can answer questions, but I will probably also have a recorded lesson for that day. You are welcome to email me questions about this, and I can even make a recording answering your questions for Monday, or you can wait and I will do my best to get live. Okay, have a great weekend, everybody.